Picture this, it is Friday afternoon. Sarah, an analyst, asks why the sales dashboard takes 30 seconds to load and why her revenue number never matches finance. The data is clean, the dashboard is not. Today we fix that. We take a clean orders table and turn it into a fast buy ready model. A dashboard can actually hit star schema, incremental refresh, and a Mart your analyst will love all in Snowflake. And every line is copy paste SQL. You can point at your own data this week. Let me show you how a real analytics layer is built. Here is the whole picture before we touch a single line. On the left, a clean orders table, the one we built in the pipeline video. On the right, the sales dashboard Sarah loves. In between is where the magic lives. We shape that flat table into a star schema, one fact and a few dimensions. Then we roll it up into a small aggregated BI Mart and we refresh it incrementally so the dashboard is always current. No full rebuild, no waiting, no stale numbers. That is the journey. Now let me convince you why it matters. You might be thinking, why not just point by at the raw tables? I tried that once on a real project. Every chart was slow and worse, every chart derived revenue its own way. One said 2.1 million, another said 2.4. A model fixes this, it gives you confirmed dimensions and one agreed definition of revenue. Think of a tidy shop floor where everything has its place versus rummaging the back warehouse for every single order. One is calm, the other is chaos. So let us build the tidy version. Take a look at this shape. It is called a star schema, and once you see it, you cannot unsee it. In the center sits one fact table, the events and the measures around it. Sit the dimension tables, the descriptors. Our fact sales joins out to dim date, dim product, and dim customer by surrogate keys. That is it. That is the whole design. The payoff is huge, simple joins, fast aggregations, and dimensions you reuse across every dashboard you ever build. Next, let me make facts and dimensions dead simple. Here is the simplest way I know to tell facts from dimensions. Facts are the numbers you measure, like amount and quantity, plus the foreign keys. Facts have many rows. Dimensions are the descriptors you slice by, like product name, customer city, or date. Dimensions stay small, and here is the rule of thumb I give every junior engineer. If you sum it, it is a fact. If you group by it, it is a dimension. Keep that one sentence in your head and you will model correctly every time. Now we start building dimensions first. We always build dimensions before the fact and we start with product. The intent here is one clean row per product. We select distinct from orders clean, pulling product ID, product name and category. We rename product ID to product key because in a dimension it is the key, then we wrap it in create or replace table dim product. Why does this matter so much? This dedup becomes your confound product definition. From now on, every dashboard uses the same product attributes. No more mismatch names, no more arguments. Next, the customer dimension, same idea. Now the customer dimension and the pattern should feel familiar. We select distinct customer rows, take customer ID as customer key, then name, city and region. We wrap it in create or replace table dim customer. The trick is choosing the right descriptors. Keep exactly what analyst lies by, city, region, segment. Leave out the noise. You end up with one row per customer. A tiny table that gets reused everywhere. Small dimensions are a feature, not an accident. They join fast and they keep your model honest. One dimension left and it is a clever one. This is my favorite trick in the whole lesson, the date dimension. Every time-based chart needs a date spine. Instead of hand typing dates, we generate them. We call table generator with row count 3650, that is 10 years of days. Then date at day, sequence 4. From January 1st, 2020, cast to a date as date key. Then we add year, month, quarter and day of week columns. Here is the win. Every sales by month or by quarter chart simply joins here. You build the calendar once and time analysis becomes trivial forever. Now we are ready for the fact table. This is the heart of the star, the fact table. And notice how lean it is. We select from orders clean and keep only keys and measures. Order date becomes date key, product ID becomes product key, customer ID becomes customer key. Then amount and quantity, the numbers we measure. That is all the fact holds, keys and measures, nothing else. All the descriptors live in the dimensions, where they belong. And now look what you have, a table that is query ready, joined to the DIMS group by sum. Let me show you why this beats the obvious approach. Let me name the trap that catches almost every team. The wrong way is letting each dashboard write its own giant join and filter against the raw tables. I have seen 40 dashboards, 40 slightly different definitions of revenue. Why does it break? It is slow, the metrics never agree, and changing one definition becomes a week of detective work. The right way is the one we are building. Model once into a star, then point every dashboard at it. One model, every chart. That single decision saves you months. Now let me show you the star winning side by side. Take a look at this comparison because it makes the case for you. On the left, the raw approach, a tangled mess of joints, marked slow and inconsistent. On the right, the star clean fact to dimension joints, marked fast and consistent. The star wins for three reasons. The joints are simple fact to dimension on a single key, so dashboards stay snappy. Conform dimensions mean region means the same thing on every chart, and one model becomes one source of truth, which means numbers people actually trust. Fast, consistent, trustworthy. That is the whole pitch. Now let us keep it fresh. A model is only as good as its freshness. So let us automate that. First, we create a stream on orders clean called order stream. A stream is Snowflake quietly tracking what changed, just the new and updated rows. Then we create a task, refresh fact on the buy warehouse scheduled every 1 hour. Inside it, we merge from the stream into fact sales. When matched, we update. When not matched, we insert. Here is the beauty of it. New orders flow into the fact every hour automatically. No full rebuild, no babysitting. Your fact stays current while you sleep. Now the final layer the dashboard actually touches. This is the layer your dashboard will love. The BI Mart, the idea is to pre-aggregate down to exactly what the dashboard shows. We create or replace table mart sales daily. We join fact sales to all three dimensions: date, product and customer. Then we select year, month, category and region. We sum amount as revenue and some quantity as units. Grouped by those four, millions of fact rows collapse into a few thousand. Small and instant, your buy tool hits this smart, never the raw fact, and dashboards load in a blink. So now how do we actually connect a tool? Here is the last mile. Connecting the dashboard, you point Power BI Tableau or even a notebook at Mart Sales Daily. Then you build your semantic layer on top, your measures and your hierarchies. But notice you are building it on a clean pre-modeled foundation, not a swamp. And there is a quiet cost win hiding here. Because the mart is small and pre-aggregated, the buy warehouse barely works, it stays cheap, fast for analysts, cheap for you. That is the dream combination. Now let me give you the production trade-offs you will face. Now a real production decision you will have to make. How do you store that mart view, materialized or plain table? A view is always fresh but it recomputes on every single query. Find if the logic is light, painful if it is heavy. A table rebuilt by the task is the fastest to read, but it is only as fresh as the last run. There is no single right answer. You pick based on the dashboard's freshness need versus the compute you are willing to spend refreshing. Name the trade-off out loud and choose on purpose. Speaking of running it well, let us operate this thing. Shipping is not finishing. You have to operate this pipeline. First, watch your refreshes. You query table, information schema, dot task history to catch any failed or late runs. Second, size the buy warehouse for concurrency. Go multi-cluster when many analysts hit it at once and set auto suspend so it sleeps when idle. Third, and this is the one people forget, alert if the fact refresh task fails, because if it dies quietly, your dashboards go stale and nobody notices for days. Silent stillness is the worst kind of bug, and that leads us to one last anti-pattern. Here is the anti-pattern that quietly bankrupts pipelines. The wrong way is to drop and rebuild the entire fact table every single night. It feels safe and simple at first. Why does it break? As your data grows, cost and runtime balloon, and you are reprocessing mostly unchanged data, paying again and again for yesterday's rows. The right way is the stream and the merge we already built. Touch only what changed. Incremental beats brute force every time. Your bill and your sleep will both thank you. Now let me hand you a card to keep. Here is your reference card, the one to screenshot. The model fact sales plus dim date, dim product and dim customer in a star. The refresh, a stream and a task merging into the fact. Hourly, the serve a pre-aggregated mart that the dashboard hits. And the rule that ties it all together. If you sum it, it is a fact. If you group by it, it is a dimension. Dashboards hit the mart, never the raw tables. Pin this somewhere. It is the whole project on one page. Now let us turn it into an interview answer. Let me hand you the interview answer for this exact question. When they ask, how would you model for a dashboard? Here is your script. Confirm your dimensions, build a lean fact, pre-aggregate a mart, and refresh incrementally. But do not stop at the what. Say the why. One source of truth, fast joins, cheap dashboards, and easy to change a definition in one place. That structure tells the interviewer something important. You have modeled for real buy, not just written a pile of selects. That is the difference between an analyst and an architect. And that brings us home. Look at what you just did. You took raw data and modeled it into a fast, trustworthy buy layer, a star schema, an incremental refresh, and a mart that loads in a blink. That is genuinely the analyst's dream, and you built it in one sitting. If you want to go deeper, the full Snowflake masterclass covers modeling, slowly changing dimensions and performance. And the link is below. Subscribe for the cost and architecture deep dives coming next. And I'm curious, what will you put on your dashboard first? Tell me in the comments, I read everyone.